Welcome to the DIY Honda Garage channel. Welcome to our troubleshooting guide for DTC P1129, which refers to a map sensor signal being higher than expected. The DTC is related to the Powertrain Control Module, PCM, and signifies a potential issue with the manifold absolute pressure map sensor. The map sensor is essential for measuring the intake manifold's pressure, providing critical data for fuel injection and ignition timing. In this scenario, it's crucial first to understand the vehicle's diagnostic capabilities, including freeze data and onboard snapshots. Gathering this data will help to guide troubleshooting steps and accurately identify the cause of the error. The Honda CRV, particularly models from 2011 to 2016, utilizes advanced onboard diagnostics to assist in the repair process. The map sensor is a crucial component located in the intake manifold of the Honda CRV. It primarily measures the pressure within the manifold, which helps determine engine load. This sensor sends critical data to the PCM for optimal fuel injection control and ignition timing. If the map sensor fails or provides erroneous readings, it can cause performance issues and trigger the DTC P1129. Symptoms of a faulty sensor often result from incorrect data being relayed, directly impacting engine efficiency and drivability. Understanding the function of the map sensor and its location allows technicians to diagnose issues effectively, ensuring the vehicle operates within expected parameters. Several factors can contribute to triggering DTC P1129. First, vacuum leaks are a common cause. These leaks can occur in critical components like the PCV valve, throttle body, or brake booster. If there's an unintended pathway for air, it can lead to inaccurate pressure readings. Secondly, a faulty map sensor itself may provide erroneous signals that can lead to the DTC being set. Lastly, electrical issues, such as poor connections or wire damage, can cause inconsistencies in the sensor's performance. Each of these causes needs to be systematically investigated to determine the root of the problem accurately. When dealing with DTC P1129, there are several noticeable symptoms that drivers might experience. First, engine performance issues often manifest, including stalling or rough idling, as the engine struggles to optimize fuel and air intake. Additionally, you may notice a decline in fuel economy, as incorrect sensor readings lead to suboptimal fuel delivery. Most notably, the check engine light will illuminate, indicating that there is a detected issue requiring attention. These symptoms not only affect drivability, but also indicate that further diagnostics and potential repairs are necessary to restore the vehicle's performance and efficiency. The first step in troubleshooting DTC P1129 is to conduct a thorough vacuum leak check. This process is essential, as even minor leaks can cause significant discrepancies in the manifold pressure readings. Begin by inspecting various components, including the PCV valve, PCV hose, evap canister purge valve, throttle body, intake manifold, brake booster, and brake booster hose. Each of these parts plays an integral role in maintaining correct manifold pressure. If any leaks are detected during this inspection, they should be repaired or replaced immediately. Successful rectification of any leaks will help update the diagnostic status and potentially eliminate the DTC. In the second troubleshooting step, you'll evaluate the performance of the map sensor. Start by ensuring the engine is running and maintain a steady engine speed of 3,000 RPM without loading the engine, preferably in park or neutral. This RPM will allow the radiator fan to engage, and once that occurs, let the engine idle. Utilizing the Honda Diagnostic System, HDS, monitor the map sensor parameters for a consistent 5 seconds. Specifically, check the values should remain above 36.9 kilopascals and 1.1 volts. If the values hold steady, it indicates that the sensor is functioning correctly. However, if they fluctuate, the map sensor must be replaced. The third troubleshooting step involves verifying any existing problems through a controlled test drive. Clear DTC P1129 using the HDS and then test drive the vehicle under specified conditions. Ensure that the engine coolant temperature is above 158 degrees Fahrenheit and maintain engine speed between 1,400 and 6,800 RPM while driving at a steady pace of 55 to 75 miles per hour. After decelerating with the throttle fully closed for at least 2 seconds, monitor the OBD status for DTC P1129 using the HDS. If the HDS indicates a failed status, this confirms a recurring issue with the map sensor, prompting a replacement. A past signal would suggest that the system may have temporarily resolved the issue, but warrants further investigation into potential loose terminals or poor connections. After completing the necessary repairs, you must verify that the repairs effectively addressed DTC P1129. Start this process by turning the ignition switch to on, to, and resetting the powertrain control module, PCM, using the HDS. Following this, perform the PCM idle learn procedure, which helps the PCM adapt to any changes made during repairs. Then, repeat the map sensor performance check by maintaining the engine at 3,000 RPM until the radiator fan activates. Next, conduct a test drive under the previously outlined conditions and monitor the OBD status for any DTCs. A status of passed will indicate successful repair and resolution of the issue, while any additional DTCs would redirect the process for further diagnostics. To prevent the recurrence of DTC P1129 and related issues, routine maintenance is essential. Regularly inspect the map sensor and other essential components to ensure they are functioning within specifications. Additionally, routinely checking for vacuum integrity can prevent unexpected leaks, which could drastically affect engine performance. Maintaining good electrical connections at the map sensor and PCM is crucial to avoid potential intermittent faults that may arise due to corrosion or loose terminals. Consistent attention to these areas will enhance the reliability of your vehicle and ensure optimal performance over time, mitigating future diagnostics. In summary, understanding DTC P1129 is key to effectively diagnosing issues related to the map sensor signal being higher than expected. Familiarity with the components involved, including their functions and locations, will significantly aid in precise troubleshooting. Following the defined steps diligently can lead to identifying the root cause, whether it's a vacuum leak, faulty sensor, or electrical issue. Most importantly, verifying repairs ensures that identified problems are indeed resolved, providing peace of mind. Finally, regular preventive maintenance will help sustain vehicle performance and avoid future DTC occurrences, ultimately ensuring the longevity and reliability of the Honda CRV. Please like and subscribe to the channel. See you next time.